So today we are going to be looking at a pattern in algebra, and this is a simple pattern, and we are going to come up with an algebraical rule for this pattern. But in order to understand, or in order to get the pattern, we have to understand where it comes from. And you'll notice here that we have 3 questions that we are going to be looking at once we are done figuring out the rule for this algebraic pattern. The first question is, how many sticks are in the next diagram? Then we have, how many sticks are in the 20th diagram? And then write an algebraical sentence to describe this system. So if you look here, I have squares. I have 1 square, I have 2 squares, and I have 3 squares. So, with these squares, I have created a table. And in this table, on the left side, you will see that I have the number of squares. 1, 2, and 3. Now on the right side, I have the number of matches, which is 4, 7, and 10. So with that, we are going to look at different ways we can find this pattern. So if you look at this 4, 7, and 10, you will notice that from 4 to 7, we are adding 3. And then from 7 to 10, we are adding another 3. So one way of finding this pattern is 4 plus 3 gives us 7. 7 plus 3 gives us 10. The only problem with this type of pattern, if you remember in the question, we want to know how many sticks are in the 20th diagram. Well, in order to find out how many are in the 20th diagram, we would need to know what's in the 19th, the 18th, the 17th, and so on and so forth before we could ever even get to the 20th diagram. So we would have to do plus 3, plus 3, plus 3. So instead of doing this, there's a simpler way to go about finding out the 20th diagram. I'm going to show you a different pattern that we can use to jump straight into the 20th diagram. So, with this algebraic equation or rule that I'm about to show you, it benefits the rule that we can use to learn to get our answer. So we wouldn't have to know what the 19th and the 18th and the 17th were beforehand. We can just jump straight into it. So let's look at 4, 7, and 10. Now if you notice here, a rule that they use to get 4 is 3 plus 1. Now where did I get this 3 plus 1? Let's look back at our squares. You will notice that each square has 1 match and 3 sides or 3 sticks, okay? So 1 match and there are 3 sticks. 1, 2, and 3. So this is where the 3 plus 1 comes from. We are always going to have 1 match and 3 sticks. So you look at the 2, and it would be 3 plus 3 plus 1. So the way that we draw this out is we look at our 2 squares over here. I'm going to change up the color so you can see the different sticks. So we have our 1 match, and then we have our first 3 sticks, and now we have a new set of 3 sticks. 1, 2, and 3. And then our 1 match. So 3 plus 3 plus our 1 match. Now we need to look at our 3 squares. And right here we have 3 plus 3 plus 3 plus 1. And you will see, let's erase this and I'll change it to the color so you can see the rule, or the pattern, we have our 1 match, And then the 3 sticks, 1, 2, and 3. The first 3, the second 3, and then now we have our new set of 3. So there's actually an even easier way to abbreviate this rule. So first, we want to look at the 3 plus 1. And this, another way of saying this is one group of 3 plus 1. So we have one group of the 3 plus 1. And then you will notice here, we have the 2 groups. So 2 groups of the 3 plus 1. Notice there's a bit of some multiplication going on right now. So here for the 3 squares, we have 3 groups of 3 plus 1. So now we can make our own rule of numbers that, Now we can see that this way that we've written it down, the 3 groups, the 2 groups, and the 1 groups of 3 plus 1, can be written in a form of multiplication. So let's go ahead and let's take this off. And you will see that we have 1, this 1, times the 3, plus the 1. So you'll notice we're going by the number of squares when we're doing it. Remember we said one group of 3 plus 1, then the 2 groups of 3 plus 1. So here's the multiplication written form of it. 2 times 3 plus 1, and then we have 3 times 3 plus 1. The rule here is linking a pattern to the number of groups of 3 there are and the number of squares. See? So, with that, we now can make our own rule numbers that makes the number of squares. X is 3 plus 1. So let's go back here. How many sticks are in the next diagram? Which would be 4, right? So if you look at this chart that I have here, the next diagram would be 4. So we know that the next number of sticks is 13. Well, how many sticks are in the 20th diagram? Well, we would write out our new rule that we have created. 3 times 20 plus 1 would equal 61. So see how we just jumped straight into the 20th diagram by using this algebraic rule that we have created? So now it says, write an algebraic sentence to describe this system. Well, we first want to say that the number of matches, so M, equals 3 times the number of squares plus 1. And this is the way we have used to find out the algebraical pattern rule that we have created here today.